Okay, in this session, we are talking about the sensors and connectivity. Here, in this sensors and connectivity, the sensors, what are the different types of sensors you are having? Here, the sensors and then types of sensor nodes. Here, the sensor node is a one type. In the sensor node consists of different sensors, different components are there, sensor node. And then the internet communication. The internet, if you comes to the internet communication, you are going to know about the different TC protocols. The protocols means set of rules. Here in this case, you are going to know about the TCP, UDP, IP protocols. Not only that one, you have to know about the TCP IP reference model and then IP address. Here it is a logical address of the computer. IP address, two versions, IP version 4, IP version 6. IP version 4 consists of 2 power 32 addresses. That means it's having the 2 power 32 addresses. And then IP version 6, 2 power 128 addresses are there. And then coming to the MAC address, this is a physical address of the computer. And then we coming to the TCP ports are different ports are there, and then application layer protocol. That means we have a different, so many different application layer protocols are HTTP, like that. So many different application layer protocols available in a internet of things. Here coming to the first important one, here is a sensors. In the sensor, types of sensor nodes. The best thing here, sensor node, you have to know about the first what is a sensor node. Sensor node also known as a mode. Here what is a mode? Here mode is a node in a sensor network. Here the sensor network consists of different sensors, their communication, wireless sensor networks are there. That means in the sensor network, you have to come one device or one IoT device communicate with another IoT device. For doing that one, you will form the sensor network. For if you comes to the any networking concept here, first you have to form the network. In that network, you have to assign a different devices. After that, you have to performing the some applications. That is a thing. The network may be, it's maybe a LAN network, it's maybe here in this case you are having the internet network. Internet is a one network. And then what is the mode here? Mode is a sensor network that is capable of performing some processing, gathering sensor information, and communicating with the other connecting nodes in a network here. Here it is a mode is a node that's having the capability that can processing. In order to processing, you require some controller. That means this sensor node having the controller. And then sensing capability. Here it's just what are the sensing capabilities are there. Sensing capability in the sense retrieving the physical information, retrieving the physical information from the environment, and then it's having the communicating with other connected nodes in a network. Here this this sensor node having the capability communicating with the other network, other nodes in the sense, here it will sense a data from sensor node to other node, and then it will receive the data from the other different sensors or activities or with other IoT devices. Here one important thing here is a mode is a node, but node is not always mode. Why? Because all nodes not having the sensing capability, all nodes not having the communication capability, but each and every node having the processing capability. That's not a problem. But here, all nodes having the sensing capability, not communication capability, not having communication capability. That's the main reason. Mode is a, that means sensor node is a node, but node is not always sensor node. Any node is not always sensor node. That is a main difference. You are coming to the components of sensor node. Very important topic. If you see The right side diagram indicates the components of sensor node. Here it consists of all sensor nodes, any sensor node. It's having the microcontroller, transceiver, external memory, power source, and one or more sensors. What are the things here? Microcontroller. It's having the microcontroller, transceiver, external memory, power source, one or more sensors. That is a very important thing in a sensor node. These are all different components. Here in this case, here in the left hand side you have a power source, and then top here the transceiver is there. That means the coordinating the yeah, the brain of the node here is a microcontroller, and then it is having some external memory storing the data. Here you having the some sensor ADC, analog to digital converter is there. That is a different component. We are coming to the first component. Here is a controller. Here, what is the main task of controller here? The controller performs task, process the data, and controls the functionality of other component in a sensor node. Your main task here. Here, what is the main task of controller here? It will performing some task, always performing any task here. Here the controller coordinate and control the some other components in a system. That is a main, that's why it is a brain, the brain of a system controller. Here the processes the data. Here whatever may be the data getting from the other devices, it will process the data and controls the functionality of other components in a sensor node. While most common controller is a microcontroller, other alternative that can be used as a controller are one is the general purpose desktop microprocess or digital signal process, FPGA, and gateway arrays, FPGA, field programming gateway arrays, ASIC, ASIC boards, and then that is a thing. And coming to the controller is used in many embedded systems. Here, if you comes to the mobile phone, not only mobile phone here. If you comes to the washing machine also, it's will be consist of controllers. Here, washing machine, any no any embedded systems. Here, microcontroller used in embedded system such as sensor nodes become its low cost, flexibility to connect with the other device, and then ease of programming and low power consumption. Because of all these reasons, you are using this sensor node. The general purpose microprocessor has a higher power consumption than the microcontroller. Microprocessor have the higher power consumption, and then therefore it is not considered suit for the choice of sensor node. That means it is not suited. That means microprocessor is not suited. Here, wireless sensor network, the wireless communication is simpler. That means one mobile to another mobile communication very simpler, easy to process the modulation and signal processing task of say actual sensing data is less complicated. That means for this one, you are using some of the FPGA can be reprogrammed and reconfigured according to requirements. But this it takes more time and energy than the desired one. But here it is a simple, even though it is a simple, but it takes a more time. But by using this technology, and then that is a some information regarding the controller transceiver. Here, what is a transceiver? Here, sensor nodes make use of ISM band, which gives a free radio spectrum allocation and global availability. The possible choice of wireless transmission media are radio frequency, optical communication, laser communication, very lightweight communication, and then infrared infrared communication, and then laser are very less energy. Here in this communication here, optical communication requires very less energy, but the line of sight of the communication and are sensitive to conditions. It is a very sensitive. Coming to the inferred, inferred communication is a like a laser communication, needs no antenna, but it is limited in a broadcasting capability. Here in this case, the optical communication having the broadcasting communication, and then but here inferred less communication. It's not having the, that means it is a limited in a broadcasting communication. Here, transceiver, the radio frequency based communication is most relevant that fits most of the wireless sensor application. The functionality of both the transceiver and receiver are combined into a single device called as a transceiver. Here in this case, transmitter is there, receiver is there. Here, that means both functionality. What is the functionality of transceiver, transmitter, and then receiver? The all functionalities combined in a single device. That is a transceiver. That means it will receive the data, it will transmit the data by using only one device. And then transceivers lack of unique identities. But here transceiver not having the lack of unique identities. The operational states are transmit, receive, idle, sleep. That means the transceiver that's different performing different state. It will transmit the data to the other devices, and then it will receive the data to the other devices. If not having any work, it goes to the ideal state. If it is a, that means sometimes it is a, in a sleeping state. The current generation of transceiver have built-in state machine that perform some operation automatically. That is a transceiver. Here coming to the third part, here is a external memory. The external memory here is a, from an energy perspective, the most relevant kind of memory are the on-chip memory of microcontroller, and flash memory and on-chip RAM is rarely used here. Here, three types of memory. The relevant memories are there. On-chip memory of microcontroller. That means the microcontroller itself has a memory. Here, internal memory, flash memory, off-chip RAM memory is used. The flash memory here, the flash memory is used to due to their cost and storage capability. And then memory requirements are very much application dependent. Here, if your application size is large, that means you require more memory. Depends upon the application you are taking the memory. That means two categories of memories based on the purpose of storage. Here, what are the two categories in this case? One is a user memory, other one is a program memory you are using. Here, user memory. What is a user memory? User memory used for storing application related or personal data. Here, whatever may be the application related data, application any application. For example, in your mobile, so many application apps are there. Here, for corresponding application related data, you will store in a user memory, or you may store your personal data also. That is called here user memory. In this case, program memory use. What is the program memory here? The program memory used for programming the device. Here, the program memory also contains the identification data of a device if persist, if present. Here, that is a thing, the program memory. That means programming the device. That means for programming the device, you are using the program memory. The program memory also contains the identification, the identification of the data. Here, coming to the power source, another important component here is a power source. The wireless sensor node is popular solution when it is difficult or impossible to run main main supply to sensor node. Since the wireless sensor network is placed in a hard to reach location, here is some, here placed in a some location, changing the battery regularly can be costly and inconvenient. An important aspect in the development of wireless sensor network is ensuring that there is always energy available to power the system. Here, I am having the, for example, let us assume mobile phone is there. How can you power the mobile phone? By using battery. Here, what is the important thing here? An important aspect in the development of wireless sensor network is ensuring that there is always energy available to the power system. But here, what is another thing here? Wireless sensor network is placed in a hard to reach location. That means very we cannot open that battery in that place. You are why you are placing that here. Charging battery regularly can be costly and inconvenient. That is the main reason here. You are placing the battery in a hard to reach location. Here very difficult to reach that particular location. Same thing here. If you go to the your mobile phone, if that means battery in a some hard to reach location. The sensor node consumes power for sensing, communicating, data processing, and more energy required for data communication than any other processes. Here, that is a sensor node. What are the tasks of sensor node here? The sensor node always consumes, takes a power for sensing. Sensing in the sense, already I explained the concept here. Sensing in the sense, taking the external parameters, the physical parameter from the environment. The physical parameters may be temperature, humidity, pressure, like that. You have a different physical parameter, and then communicating, data processing. More energy is required for data communication than any other processes. For communicating data from one node to or one device to other device, it required more processing. That is a main reason you are using the power. And then coming to the another last and final component in this sensor node here is a sensors. Here the sensor node consists of different sensor. Here what is a sensor here? Sensor measures some physical quantity. You know physical quantity, temperature, humidity, water is a physical quantity, and convert that measurement in measurement reading, that measure into a digital representation, or you may it may convert the electrical representation. That digital representation is passed to another device for transformation into useful data that can be consumed by intelligent devices or human. The sensors are not limited to the human, like a sensory data. Here, that is a main purpose of you are using the sensor node in this sensor data. And then the sensors provides a superhuman sensory capability, more than human. Here, the sensors can be embedded in any physical objects that are easy connected to internet by wired or wireless network. They can be interpreted their environment and make a intelligent decision. That is a simple representation of sensors. Very important topic in this case. Here sensor used in a wireless sensor network to capture data from their environment. Here for capturing the data, that means most probably these sensor nodes always used in a wireless sensor networks. Here the different IoT devices are there. That means without wire, you are connecting the different IoT devices. These IoT devices communicating without wire. They are hardware devices that produce a measurable response to change in a physical condition, that's a temperature and then pressure. And then this also having the sensors also having the analog signal. The analog signal produced by the sensor is digitalized by the analog to digital converter, in analog to ADC, and sends to controller for processing. Here the sensor takes a data and then it sends to the processing. Some of the sensors contains necessary electronics to convert the raw signal into readings, which can be retrieved via a digital link. Here the digital link may be some of the interfaces are there in the Raspberry Pi or some IoT devices. I2C, SPI, serial peripheral interface. some of the interfaces. With the help of these interfaces, that means it's that means some of the sensor contain necessary electronics to convert the raw signal into readings, which can be retrieved via this SPI. Most sensor nodes are small in size, consume little energy, operate in high volume of data, and then be autonomous, and then operate unattended and be adaptive to the environment. That is a simple description about the sensor node. Here, the very important thing you will discuss later. In the next class, you will discuss about the different classification of sensor nodes. Here, these are all different classification. The next class, you will discuss about the this classification and then types of sensor node, types of sensors, and then types of sensor nodes. Okay, thank you.